This is lesson 5, and this is about power and what I call simple circuits. When you see the circuits, you may not exactly think they're very simple, but they are, at least compared to some others that we're going to do a little bit later. The first few sections of this go through a derivation, sort of an explanation and a derivation of power, and you're going to find that there's an equation for power that's a general equation for any circuit element, that is, whether it's a resistor or a battery, and then there's a specific equation for resistors. So that's what the first part is about. And then I decided, well, you need a little bit more practice at solving with resistors in series and parallel. So that's why we call this a simple circuit. There's one battery and then several resistors. So what I'm going to do is to show you a method, because if you just try sort of randomly doing things, you're going to probably get yourself very confused. So there's a method to solving these. So this is on page 30, part 5, number 1. And I'm going to draw the circuit as it is shown there. So we have our power supply, we have a resistor, another one over here, and then we have 2 in series up here. So we have R1, R2, and I've got this one labeled R3, R4, R5, and then this is the voltage of the battery. So when you're working these, the overall idea is to add the resistors in series and parallel as appropriate until you get a single resistance. So then you have to decide, well, what's in series and what's in parallel? You can tell just by looking. For some people it's fairly easy, for some you have to think about it a little bit more, but here's a couple of general rules. If 2 resistors are in series, you can go from one resistor to the other without any junctions. So let's look at resistor 4 and 3. If we try to follow the wire from 4 to 3, there's a junction. So 4 is not in series with 3. Now, if it's not in series, that doesn't necessarily mean it's in parallel either. So you have to kind of look elsewhere and see what else you can do. If you notice R1 and R2, you can go from R1 to R2 without any junctions. So that means that R1 and R2 are in series with each other. Now, before I draw the next circuit, let's think about parallel. What we did with parallel before, I think we had drawn something like this. We had 2 resistors in parallel. So the rule is if both sets of ends are tied together, then those 2 resistors are in parallel. So now, let's look at R1 and R3. Well, this left end of R1 is tied to the left end of R3, but the right end of R1 is not tied to the right end of R3 because it goes to R2. So R1 is not in parallel with R3. So what we're going to end up doing is adding in series or parallel as appropriate until we have a single resistor. So if we look at this, we can see that R1 and R2 are in series. And some of these I have actually sort of led you through the process. But you should be able to look at a circuit like this and be able to figure out what you need to add in what order. So I always draw all of the intermediate circuits. So we're going to draw another circuit here. Have the same battery. we're going to have R4, R3, R5, there's the battery, here's R3, here's R4. Now, up here, we're going to draw a single resistor and label it R with a subscript 1, 2. So that means that it is the equivalent resistance of adding R1 and R2 in series. So you would do that, and there's a place there for that calculation. Now, if we look at this, we can see that R1, 2 and R3 are in parallel because the left sides of both of those are tied together and the right sides of both of those are tied together as well on the other side. So I'm going to do, actually I'm going to draw it down here. So we have this. We'll have one up here, and then we'll have a resistor there, one over here. So this is going to be R4. This one on the right is R5. And then we're going to add R1, 2, and R3 in parallel, following the proper equation. And then we're going to call this R1, 2, 3. So in this subscript, there's no real designation as to which ones were in series or parallel. It's just that we know that we've added them appropriately and have a single resistor for that. Okay, then we have 3 in series. So the next thing we can do is to add all 3 of those and put those in, I'll put a voltage here, and have a single resistor there. Now, we could put R1, 2, 3, 4, 5, and I think I may have done that in the lab. The other thing that you can do when you have the last one is just put R with a subscript T for total. That's a little bit shorter, but if you have the subscripts here, it does at least emphasize how many resistors you had originally. So what you normally end up doing is you go through adding resistors in series and parallel until you have the last one. Then you can apply Ohm's law with the voltage of the battery, the resistance of this, get the current, and then if you work this one step back, remember that the current through a resistor is the same, which is equivalent, is the same as through the individuals when they were in series. So the current here is the same as the current through each of these. And then you can work backwards from that. You know that voltages across resistors in parallel are equal. So after you have the current for each of these, you can apply Ohm's law and do V equals IR. You can find the voltage for each of these 3. And then you know that this one is a combination. So you can get the voltage, when you have this voltage, that's the voltage across R3. It's also the voltage across R1, 2. Then again you have Ohm's law, so if you have the voltage and the resistance, you can find the current, and then you know that resistors in series, the current is the same, and the same as the equivalent, so that will give you the current through R1 and through R2. Now, in the lab, I didn't have you to work completely back through all of this because it can be kind of confusing. And it also takes a lot of paper, and if you're not really careful about how you arrange it on your paper, you can kind of get lost. But if you go through and just calculate or figure out the parts that I had you to do, then you should be fine. The other part at the end of this is to go through and calculate the power using the equations that you have derived in the earlier part of the lab. So I think by the time you get that, there are tables to fill out, so that'll make it a little bit easier for you to keep track of your numbers. One thing I should mention is in several places In the tables, if I have a unit or have a variable with parentheses after it, for instance, if I have R and parentheses with nothing in it, you should fill out the units, and you should know by now that resistors have units of ohms, and voltage will have units of volts. The other one that we can talk about is current, should have units of amps. And there might be one for power. I'm going to let you figure that out because you should have figured that out in the earlier part of this lab. But anytime in a table that there's a variable with a blank space in the parentheses, then you should fill out that unit. And I believe that's the end of this one.